Warning, the video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. It's yet another video in a series on hyperbolic functions for differential calculus. You should have watched my videos on the derivation of the hyperbolic functions, hyperbolic identities, and derivatives of hyperbolic functions up to this point. Not a lot of meat on that material. And then we get into inverse hyperbolic functions. And I will be very honest. I want to be very honest here and let you know that most instructors don't require you to know quite a lot about inverse hyperbolic functions from my experience. They can be incredibly powerful if you remember their derivatives. But the inverse hyperbolic functions themselves, you rarely use them. I'm not saying you won't. If you become a math major, you might use them. If it's part of your research or something like that, you might use them there as well. But they're defined in terms of the regular old hyperbolic functions, just like normal inverse functions are. Y is equal to the sinh inverse of x if and only if sinh of y is equal to x. Okay. Y is equal to cosh inverse of x if and only if cosh of y is equal to x and y is greater than or equal to 0. That domain restriction is there on the cosh because the cosh is not invertible naturally. And so you have to restrict its inputs to be greater than or equal to 0 to get it to be invertible. The y equaling the tangent inverse of x is true if and only if tangent of y is equal to x. And that is invertible naturally, so we don't have to worry about that. Those are the definitions of the hyperbolic inverse hyperbolic functions. Not much else I can really say about those. So let's move on from there to these guys. Now, the following formulas are not memorizable. Again, I only present these because often if you're working in a calculus course and your instructor decides to cover this material, they are going to cover inverse hyperbolic functions. Not because they want you to work with these forms right here, but because they want you to know their derivatives. So let's go ahead and focus just on these three right here. And we're just going to prove one of them. And I'll prove the sinh inverse just because they're all kind of the same and they're easy to prove. So proving one of these, again, not memorizable, so I'm not going to read them out loud, but we're going to let, let's see, y equal sinh, oops, it's supposed to be a sinh inverse of x. And that's true if and only if sinh of y is equal to x. Okay. But we know that's true if and only if e to the y minus e to the negative y over 2 is equal to x. So far, all I'm doing is using the definition of the inverse and then the definition of the sinh. Nothing really terrible there. I'll multiply both sides by 2, so that's true if and only if e to the y minus e to the negative y is equal to 2x. All right, let's see if we're getting close. Doesn't look like we're getting close at all. Since e to the negative y is non-zero, I'll go ahead and multiply both sides of this equation by e to the y. So this becomes e to the 2y minus 1 is equal to 2x e to the y. And now we're very close to being done, even though it doesn't look like it. This is going to be true if and only if e to the 2y minus 2x e to the y minus 1 is equal to 0. Now, I'm going to solve that equation because I want to know what y is, right? So what I'm going to do is I'm going to let, off to the side, u equal e to the y, which would tell me that u squared is equal to e to the 2y. It's called a u substitution. You're going to get used to those as we move forward in this course. For anybody who's had Calc 1 before, you know that that's a very important move. So our equation right here can be rewritten as u squared minus 2xu minus 1 is equal to 0. Now, if I want to solve for u, not for x, but for u, I can use the quadratic formula. This would imply u is equal to, let's see, the opposite of the b term, so 2x, plus or minus the square root of the b term squared, so that'll be 4x squared, minus 4 times a times c, minus 4 times 1 times a negative 1, all over 2a. I hope everybody's with me so far. That's 2x plus or minus. Notice in this radical here, I can factor a 4 out, take its square root. So we're left with this. And that's going to be all over 2. And you can see beautifully that the 2's will cancel. So this will be just an x plus or minus the square root of x squared plus 1. However, this is supposed to be, remember what u is, e to the y. So e to the y must be x plus or minus the square root of x squared plus 1. Now I do want to mention something before we continue. The x plus is not going to be an issue. However, x minus is going to be an issue. X minus the square root of x squared plus 1 is actually negative. It's because the square root of x squared, that piece right there, is already x, and then you're adding more to it. So this number here, when you take its square root, is going to be bigger than x. So x minus something larger than x, that'll be negative. And exponentials are never negative. So I'm going to throw out the minus sign off our quadratic solution. And this will imply that e to the y is just x plus the square root of x squared plus 1. Take the natural log of both sides, and you get, finally, that y is equal to the natural log of x plus the square root of x squared plus 1, which is exactly what we wanted. Oh, you probably don't see that, but remember, y is the sinh inverse, sorry. So that tells us sinh inverse is the natural log of x plus the square root of x squared plus 1. Now, the only reason why I'm having this video is so that we could talk about the derivatives. I did a proof because, well, you might have a proof like that in your homework, who knows? Maybe you have to prove the cosh inverse is equal to the natural log of that business. They're all kind of done the same way. But I'm not creative enough to actually have like a numerical example requiring the inverse of a hyperbolic function. So I will not bother with an example other than just this proof, because you're likely not going to see an example. Now, I'm not going to say you won't, because your instructor might have it, but to be honest with you, even in the textbook I use, which is one of the most popular textbooks in the nation, they don't really have very much other than maybe one example involving the inverse hyperbolic function as a logarithm. And that is worthless then, because if they're not going to use it often, then don't bother with it.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.